Welcome to Math on Ice, June 2015 Integral Equations. There are two questions, one question from part B and one question from part C. So this question was a repeated question. This was also asked in the year June 2014 and it was being repeated again in June 2015. So let's solve the problem. Y of x is equal to lambda times of integral 0 to 1 3x minus 2 into t into y of t dt. So we have to find the lambda, the characteristic number of characteristic number. We have to find the total number of values of lambda. So y of x is equal to lambda integral 0 to 1 3xt minus 2t, the whole thing into y of t dt. Now this is y of x is equal to 3x lambda integral 0 to 1 t into y of t dt minus 2 lambda integral 0 to 1 t into y of t dt. So here we have t into y of t dt. We would take this t into y of t dt as c, this as c. So we will have y of x is equal to 3x lambda c minus 2 lambda c. So y of x is equal to 3x lambda minus 2 lambda, the whole thing into c, where c is actually equal to integral 0 to 1 t into y of t dt. And that is equal to integral 0 to 1 t. When you have y of x is equal to something in terms of x, you will just convert the same thing in terms of t for y of t. So this is 3t lambda minus 2 lambda into c into dt. Now this c and this c cancels. So we get 1 is equal to integral 0 to 1 3t squared lambda minus 2t lambda into dt. Now you can take out lambda outside. Integral 0 to 1 3t squared minus 2t into dt. So 1 is equal to lambda times of 3t cube by 3 minus 2t squared by 2, 0 to 1. 2 cancels, 3 cancels. We have the lower limit and the upper limit. 1 is equal to lambda times of 1 cube minus 1 squared, and this one when you apply 0, you get 0 minus 0. So this is actually equal to lambda times of 0 is equal to 1. We get 0 is equal to 1. This is not possible. Therefore, no characteristic value. Option D is the correct answer. Next question. For the integral equation, y of x is equal to 1 plus x cube plus integral 0 to x k of x comma t y of t dt. With kernel k of x comma t is given by 2 power x minus t, that can be 2 power x into 2 power minus t. The iterated kernel k3 of x comma t. So what is k1 of x comma t, which is equal to the same as k of x comma t, which is equal to 2 power x into 2 power minus t. And then we need to find k2 of x comma t, and then we need to find k3 of x comma t. So this is what the question is. We know that kn plus 1 of x comma t is equal to integral. Since it is a Volterra type, we will have the lower limit as t, upper limit as x, and k of x comma z, kn of z comma t into dz. So this is equal to k2 can be found from this first. So k of x comma z, which is equal to k of x comma z will be equal to 2 to the power x, 2 to the power minus z. So we will have 2 to the power x, 2 to the power minus z. And here kn of z comma t. For k2 we will go with k1 here, k of x comma z and k1 of z comma t. So we have k1 of z comma t will be equal to 2 to the power z into 2 to the power minus t into dz. So this one. When you solve, this powers will be 0 and 2 power 0 will give you 1. So these two vanishes. So we get, which is equal to t to x 2 to the power x minus t into dz. This term is independent of z, so you can take it outside. So this is 2 to the power x minus t integral t to x into dz. And this is equal to 2 to the power x minus t. When you take the integral, you will find it as z, lower is t, upper is x. So we get x minus t into 2 to the power x minus t. This is what our k2 of x comma t is. Now we need to find the k3, right? So k3 of x comma t is equal to integral t to x, k of x comma z. So k of x comma z is 2 to the power x, 2 to the power minus z. And then we need to find k2 of z comma t. So this will be So this part is going to be is k2 of z comma t. So we have z minus t into 2 to the power z minus t into dz. So this is equal to, so this term is 2 to the power x is independent of z, and 2 to the power minus t is independent of z. So you can take that 2 to the power x minus t outside, t to x, 2 to the power minus z, and you have a 2 power z here, and then we'll be left with z minus t into dz. So this is equal to 2 to the power x minus t. Again, these two bases are same. Add the powers. When you add the powers, it will be equal to 0. Anything power 0 is 1. So we get t to x z minus t into dz. Here t is considered to be a constant. So you'll have z minus a. In that case, how do we integrate x minus a into dx? Integrate x minus a the whole square divided by 2. Right. In the same way, we are going to integrate here. So this is equal to 2 to the power x minus t into z minus t the whole square divided by 2. Lower is t and the upper limit is x. So this is equal to 2 to the power x minus t divided by 2, and apply the limit. When you apply the upper limit, it is x minus t the whole square. When you apply the lower limit, it is t minus t the whole square. This is going to become 0. So we'll have 2 to the power x minus t into x minus t the whole square divided by 2. This is what your k3 of x comma t. We will look at the answers. 2 to the power, oh, now this 2 has been moved to the top numerator. 2 to the power x minus t minus 1 into x minus t the whole square. 2 to the power x minus t minus 1, 2 to the power x minus t minus 1, x minus t the whole square. So the third option is the correct answer for the given question. Thank you.